What if everything we thought we knew about the universe was just the tip of the iceberg? Picture this: you step outside on a clear night, looking up at those countless stars, and for a moment you feel the vastness of space. But here's the thing: that stillness, that sense of permanence, it might be an illusion. Scientists are uncovering clues that suggest the cosmos isn't just some cold, unchanging void. It's pulsing with life, shifting and evolving in ways that defy our wildest expectations. And today, we're diving into 25 mind-blowing observations that could shatter everything you thought you understood about reality. Think about the last time you heard something that made you question your assumptions. Maybe it was a scientific breakthrough or a personal revelation that flipped your perspective upside down. Now, imagine that feeling multiplied by the scale of the entire universe. From galaxies that move like they're guided by some unseen hand to strange signals echoing across the cosmos, these aren't just oddities. They're whispers of a deeper truth, that the universe might be more alive, more conscious than we ever dared to believe. And the most thrilling part, we're only just beginning to decode its secrets. This isn't just about stargazing or reciting dry facts. It's about reimagining our place in something far grander than we've been taught. What if the universe isn't just a backdrop to our existence, but an active participant, shaping and responding in ways we're only starting to grasp? Over the next few minutes, we'll travel through the most astonishing discoveries that point to this radical idea, each one a piece of a puzzle that's rewriting the story of everything. So, if you've ever felt that tug of curiosity when you look up at the night sky, get ready, because by the time we're done, you won't just see the stars differently, you'll feel them differently too. Let's begin. What if galaxies aren't just static collections of stars, but more like living entities, pulsing with their own rhythms? Take the Milky Way, our cosmic home. For decades, astronomers assumed star formation happened at a steady, almost random pace. But now, cutting-edge observations reveal something extraordinary. Galaxies experience bursts of star birth in regular cycles, like a heartbeat. Every few 100 million years, vast regions ignite with newborn stars, then quiet down, only to flare up again. It's as if the galaxy itself is breathing, adjusting its own growth like a living organism responding to its environment. This isn't just poetic speculation. The data is undeniable. When researchers mapped star-forming regions across distant galaxies, they found patterns so consistent they could almost predict the next beat. Some compare it to the way forests regrow after fires, a natural ebb and flow that maintains balance. But here's where it gets eerie: these cycles aren't isolated. Neighboring galaxies often sync up, their star-forming rhythms aligning as if orchestrated by some unseen force. Could dark matter be pulling the strings? Or is there something even more profound at play, a kind of cosmic metabolism, where galaxies exchange energy and matter like cells in a vast interstellar body? Consider the implications. If galaxies self-regulate, it challenges the idea of a universe ruled purely by chaos. Instead, we might be looking at a cosmos with its own rules of growth and adaptation, almost like a living network. Picture an ant colony where individual ants follow simple instincts, yet the colony as a whole exhibits astonishing intelligence. Could galaxies operate the same way? Each star, each nebula, playing its part in a grander dance of cosmic evolution. And here's the kicker: these pulsations leave traces. Astronomers have spotted fossil rhythms in ancient galaxies, patterns frozen in time that tell the story of their growth. It's like reading tree rings, but on a scale so vast it spans billions of years. If we can decode these signals, we might uncover the universe's deepest secrets, not just how it expands, but how it lives. So the next time you gaze at the night sky, remember those distant lights aren't just burning, they're breathing, and their rhythm might just hold the key to understanding everything. Now imagine this entire clusters of galaxies, each containing billions of stars, all drifting in the same direction like leaves caught in a cosmic river. Astronomers call it dark flow, and it's one of the most baffling discoveries in modern cosmology. These galaxies aren't just moving apart due to the expansion of space, they're being tugged towards something massive, something beyond the edges of everything we can see. The strange part, there's nothing there, at least nothing we can detect. No supercluster, no concentration of dark matter, nothing visible in our telescopes. Yet the pull is undeniable, as if the universe itself is whispering about realms we can't yet perceive. This isn't just a slight drift. Some of these galaxy clusters are racing at speeds topping 2 million miles per hour toward the same mysterious point in space. Think of it like standing in a crowd where suddenly everyone starts walking toward a door you can't see. You'd assume something incredible must be drawing them, and that's exactly what scientists are grappling with. One daring theory suggests the pull could be coming from another universe entirely, a neighboring bubble of reality brushing against ours through higher dimensions. It's like feeling the wind from a room you didn't know existed. Or consider this, what if our observable universe is just a small patch of something far grander? Ancient light from the cosmic microwave background, the afterglow of the Big Bang, hints at uneven textures, as if space-time was stretched by forces from beyond. Some researchers speculate that these textures could be scars from a collision with another universe in the distant past, leaving behind a gravitational echo that still tugs at us today. Here's where it gets even wilder. If dark flow is real and the evidence is mounting, it challenges one of cosmology's bedrock principles, that the universe should look roughly the same in all directions. Instead, we're seeing a cosmos that might be lopsided, influenced by something vast and unseen. It's as if we've been studying a single page of an endless book, only to realize the story extends far beyond the margins. Could this be the first clue that we're part of a multiverse? Or is there some exotic structure, some cosmic attractor lurking in the darkness, rewriting the rules of gravity itself? Whatever the answer, dark flow reminds us how much we still don't understand. The universe isn't just expanding, it's flowing, shaped by forces we're only beginning to sense. And if galaxies can move together toward some unseen horizon, what else might be out there, waiting to reshape our understanding of reality? Now picture a signal so powerful, it outshines entire galaxies, but only for a fraction of a second. Fast radio bursts are among the most mysterious phenomena in the cosmos. Brief flashes of radio waves that travel billions of light years before reaching our telescopes. At first, astronomers dismissed them as cosmic glitches, maybe the death throes of distant stars. Then something extraordinary happened. We caught one repeating. Not just once, but in precise, rhythmic patterns, like a heartbeat echoing across the universe. Take FRB 1218. A burst that fires off like clockwork every 16 days. For 12 hours, it unleashes multiple signals, then falls silent for another 16. It's not alone. Dozens of these repeating bursts have been catalogued, each with its own cadence. Some flicker randomly, while others follow intervals so exact they could be mistaken for artificial. And here's the twist: no known natural process explains them all. Neutron stars may be for some, colliding black holes possibly, but when a burst's energy output rivals the sun's entire output in a millisecond, with patterns that persist for years, even the most conservative scientists start wondering, are we hearing the universe's version of Morse code? Theories abound. One suggests these bursts could be the exhaust trails of light sails from alien megastructures. Imagine a civilization harnessing the power of stars to propel ships, leaving behind bursts of energy as signatures. Others propose their cosmic lighthouses, beacons from advanced societies trying to announce their presence. But the most haunting idea, that FRBs aren't messages at all, but the universe itself thinking. Some physicists speculate that space-time could have a form of primitive memory, with these bursts acting like neural firings in a vast cosmic brain. Then there's the localization problem. Many FRBs originate in dwarf galaxies, places with low metal content, ideal for fostering long-lived civilizations. Coincidence or a clue, even stranger, some bursts arrive with a telltale twist in their polarization, as if they've passed through powerful magnetic fields, exactly the kind you'd find near a technologically advanced planet. Skeptics argue it's pareidolia, our tendency to see patterns where none exist. But when a signal from 3.5 billion light-years away matches no known astrophysical profile, the question lingers. What if we're not just listening to the universe, but to something or someone within it? The hunt for answers is accelerating. New telescopes like Canada's CHIME are detecting dozens of bursts monthly, mapping their origins with unprecedented precision. Each discovery peels back another layer of the mystery, revealing a cosmos far more dynamic and perhaps far more alive than we ever imagined. So the next time you hear about a fast radio burst, remember, it might be a dying star's last gasp. Or it might be the first hello from a reality we're only beginning to fathom. Here's something that keeps cosmologists up at night. The universe isn't just expanding. It's doing so at a rate that defies all expectations. For decades, we've relied on two trusted methods to measure this cosmic growth. The first studies the afterglow of the Big Bang, the cosmic microwave background, like reading the universe's birth certificate. The second tracks exploding stars in distant galaxies, acting as cosmic mile markers. Both should agree on how fast space is stretching, but they don't. The discrepancy is called the Hubble Tension, and it's not just a minor math error. It's a gap so wide it could tear open our understanding of reality. The numbers tell the story. One method suggests the universe expands at about 67 kilometers per second per megaparsec. The other insists it's closer to 73. That difference might seem small, but over cosmic distances, it adds up to a staggering miscalculation. Imagine driving a car where your speedometer and GPS disagree by just 5 miles per hour. Over a cross-country trip, you'd end up hundreds of miles off course. Now scale that to billions of light years, and you've got a problem that challenges the very laws of physics. So what's causing the mismatch? Some theorists point to dark energy, the mysterious force accelerating the universe's expansion. Could it be growing stronger, evolving in ways we haven't accounted for? Others propose entirely new particles or dimensions, hidden threads in the fabric of space-time tugging at the cosmos. Then there's the radical idea that our patch of the universe might be unusually empty, a cosmic bubble where gravity's grip is weaker, making expansion appear faster. But the most thrilling possibility, the Hubble tension, might be a clue that our models are incomplete, that the universe isn't just obeying the rules we've written, it's rewriting them. Think of it like discovering your favorite board game has secret rules no one told you about. Every move you thought you understood now has layers you never anticipated. What's at stake isn't just a number, it's the story of everything. If the universe is expanding faster than predicted, galaxies will drift apart sooner, leaving future civilizations with a sky nearly empty of stars. Or perhaps this tension hints at something grander, a cosmic cycle where expansion ebbs and flows like breath. One thing's certain, the Hubble tension isn't a flaw in our measurements. It's the universe whispering that we're on the verge of something far stranger than we imagined. Imagine the quietest place you can think of, a vacuum so empty, not even a single atom floats through it. Now here's the twist: that emptiness isn't empty at all. At the quantum level, space is a seething, bubbling cauldron of energy, where particles flicker in and out of existence so fast they defy measurement. These aren't just random blips, they're quantum vacuum fluctuations, and they might hold the key to understanding how the universe grows, evolves, and even creates itself. Picture a calm ocean at night. On the surface, everything looks still, but dive deeper, and you'll find currents swirling, fish darting, life thriving in what seemed like nothingness. The quantum vacuum works the same way. What we call empty space is actually a dynamic arena where particle-antiparticle pairs spontaneously emerge, collide, and vanish in fractions of a nanosecond. This isn't theoretical, it's been proven in labs, where scientists measure the faint echoes of these fluctuations in the form of Casimir forces, tiny pressures exerted by nothingness itself. Now stretch this idea to cosmic scales. Some physicists suggest these quantum ripples could be the engine behind the universe's expansion. Think of it like a pot of water on the verge of boiling. Tiny bubbles form, merge, and release energy, driving the system forward. If space-time itself is simmering with this quantum activity, could it be pushing galaxies apart? The math hints at yes. In fact, dark energy, the mysterious force accelerating cosmic expansion, might not be some exotic substance, but the cumulative effect of these vacuum fluctuations, a kind of background hum of creation woven into the fabric of reality. But the implications go even deeper. If the vacuum is this active, could it also be creative? Some theories propose that the seeds of entire universes might sprout from these quantum foams, bubbling up into new realities like droplets condensing in a cosmic fog. It's a dizzying thought. Our universe might be one branch on an infinite fractal tree, born from the same quantum fizz that fills every inch of so-called empty space. Then there's the eerie symmetry. The same quantum processes that allow particles to appear from nowhere also govern the behavior of black holes, where information seems to vanish without a trace. Could this dance of creation and destruction be part of a larger cycle, a universe breathing in and out across eternity? The clues are there, etched into the equations. The vacuum isn't just a stage for the cosmos, it might be the director, the playwright, and the audience all at once. So the next time you stare into the night sky, remember, the vast darkness between stars isn't passive or dead. It's crackling with potential, a canvas where reality itself is constantly being sketched and erased. And if the quantum vacuum truly is this alive, this creative, then we're not just observers of the universe. We're expressions of its endless, shimmering energy. Deep in the cosmic void, something is pulling us, and not just us. Our entire galaxy, along with thousands of others, is being drawn toward a single point in space with the force of 1,000,000 suns. Astronomers call it the Great Attractor, and it's one of the universe's most perplexing mysteries. Imagine floating in a river, unable to see the current, yet feeling its relentless tug. That's exactly what's happening to the Milky Way, racing toward this unseen force at over 2 million kilometers per hour. But here's the catch: when we point our telescopes in that direction, we find almost nothing. No colossal galaxy cluster, no supermassive black hole, nothing bright enough to explain the sheer gravitational grip this region holds. So what could it be? The leading theory suggests a hidden supercluster, a dense knot of galaxies shrouded by the thick dust of our own Milky Way's galactic plane. Observations in infrared and radio waves hint at massive structures lurking there, like the Norma cluster, but their combined mass still falls short of accounting for the attractor's pull. It's as if we're seeing the tip of an iceberg, with the bulk of its mass lying in shadows. Some researchers propose exotic explanations like concentrations of dark matter so dense they warp space-time itself. Others wonder if the Great Attractor isn't a destination at all, but a signpost pointing to something even grander beyond it, a cosmic Matryoshka doll of gravitational anomalies. The intrigue deepens when you realize this isn't an isolated phenomenon. The attractor itself seems to be moving, pulled toward an even larger structure, the Shapley supercluster, a staggering collection of galaxies over 500 million light-years away. This cosmic chain of influence, our local group, the Great Attractor, Shapley paints a picture of a universe knit together by invisible threads, a web of gravity where everything is connected in ways we're only beginning to map. Yet the most tantalizing question remains: what if the Great Attractor isn't just hidden matter? Could it be a flaw in our understanding of gravity itself? Modified theories like MAN suggest gravity behaves differently at galactic scales, which might explain the anomaly without invoking unseen mass. Or perhaps it's a ripple from something more profound, a remnant of the universe's birth, a cosmic string, or even a gravitational echo from a collision with another universe. One thing's certain: the Great Attractor defies simple explanations. It's a reminder that the cosmos is far stranger than our models predict, and that even the emptiest stretches of space might be teeming with secrets. As we peer through the veil of dust and distance, we're not just searching for a missing piece of the puzzle. We're chasing the possibility that the universe's greatest mysteries aren't in the light, but in the shadows. Pulsars are the universe's metronomes, spinning neutron stars so precise their rhythmic pulses rival atomic clocks. But every now and then, these cosmic timekeepers stutter. A beat arrives too early, too late, or vanishes entirely. These aren't random glitches. They're anomalies that defy physics as we know it, and the closer scientists look, the more they suspect these hiccups might be messages from the universe's hidden machinery. Take the Vela pulsar, one of the most studied neutron stars in the sky. For decades, its ticks were as reliable as a Swiss watch until it suddenly sped up, spinning faster without warning. Then there's Pulsar J1748-2446, which didn't just skip a beat but reversed its slowdown, as if some invisible hand gave it a twist. Traditional explanations point to starquakes or shifts in the star's interior, but the math rarely adds up. The energy released in these events often dwarfs what a neutron star's crust could realistically muster. So what's really going on? One radical theory suggests dark matter might be the culprit. If certain types of dark matter particles accumulate inside a pulsar, they could collapse suddenly, releasing a burst of energy that jolts the star's rotation. It's like dropping a weight onto a spinning top, unpredictable, violent, and impossible to ignore. Others propose these glitches are signatures of quantum vortices in the pulsar's superfluid core, tangled and snapping like over-twisted rubber bands. But the most mind-bending idea: these timing anomalies could be evidence of space-time itself warping around the pulsar, tiny tremors in the fabric of reality echoing through the star's rotation. Then there's the eerie case of Black Widow pulsar's binary systems, where the neutron star slowly devours its companion. As material from the doomed star spills onto the pulsar, it should gradually slow its spin. Yet some black widows accelerate unpredictably, as if feeding on something beyond mere matter. Could they be interacting with dark energy or harvesting exotic particles from dimensions we can't yet perceive? The implications stretch far beyond neutron stars. If pulsar glitches reveal unseen forces tugging at the cosmos, they might also hold clues to gravity's true nature. Some models suggest these anomalies align with predictions of modified gravity theories, where the rules change at extreme densities. Others see them as potential evidence for cosmic strings defects in spacetime left over from the Big Bang, vibrating like guitar strings and plucking at passing pulsars. What's clear is this: when the universe's most precise clocks misfire, it's not just a technical hiccup. It's a signal, a crack in the facade of our understanding, hinting at a reality far stranger than we've imagined. And with every glitch, every skipped beat, we're one step closer to reading the universe's hidden rhythms. What if the universe isn't as random as we've been led to believe? Buried in the faint glow of the cosmic microwave background, the oldest light in existence lies a pattern so bizarre, scientists nicknamed it the axis of evil. This isn't some apocalyptic prophecy. It's a spine-chilling alignment in the fabric of reality itself. When researchers mapped the slight temperature variations in this primordial afterglow, they expected chaos, a splatter of hot and cold spots with no discernible order. Instead, they found something that defies logic. The fluctuations aren't random. They're aligned along a single axis, as if the universe has a built-in compass pointing toward a mysterious, preferred direction. This discovery should have sent shockwaves through cosmology. The fundamental assumption for over a century has been that the universe is isotropic, the same in all directions, no matter where you look. But the axis of evil throws a wrench into that idea, suggesting space might have a subtle grain like wood, with properties that change depending on which way you cut through it. Some of the coldest and hottest patches in the cosmic microwave background line up eerily well with the plane of our solar system, a coincidence so statistically improbable. It's like rolling a die 100 times and getting the same number every single time. Skeptics argue it's an observational fluke, but the data persists across multiple satellites from WMAP to Planck. So what could cause such an anomaly? One daring hypothesis suggests our universe might have collided with another in the distant past, leaving behind a gravitational bruise that warps the cosmic microwave background like a fingerprint on glass. Others propose we're seeing the shadow of a multiverse, an imprint from a neighboring bubble reality that brushed against ours during cosmic inflation. Imagine two soap bubbles touching briefly. The place where they met might retain a subtle deformation. If true, the axis of evil could be our first glimpse beyond the edge of everything we know. Then there's the existential interpretation. What if this alignment isn't accidental but intentional? Some theorists explore whether the universe could have a form of cosmic memory, with quantum processes at the Big Bang encoding a directional bias into spacetime itself. It's like finding a barcode etched into the foundation of reality, a signature from whatever came before. Even more unsettling, this axis aligns roughly with the mysterious, dark flow of galaxies and the Great Attractor, as if all these anomalies are threads of the same invisible tapestry. The controversy isn't just academic. If the universe has a preferred direction, it challenges Einstein's principle of relativity, the cornerstone of modern physics. Could gravity work differently along this axis? Does light travel faster in one direction than another? The implications rewrite textbooks. Critics dismiss the axis of evil as a statistical mirage, but with each new dataset, the pattern lingers, quiet, persistent, and utterly unexplained. Perhaps the most profound question isn't what causes the axis, but what it means. Are we seeing evidence of a multiverse, a cosmic architect, or simply the limits of our own perception? One thing's certain, the universe is whispering that it's far stranger, far more structured than we ever imagined. And the axis of evil isn't just a curiosity, it's a crack in the door to realities beyond our own. Stretching across billions of light years, thinner than spider silk yet stronger than steel, An invisible force weaves through the cosmos magnetic fields on scales so vast they defy comprehension. These aren't the familiar fields around planets or stars. These are galaxy-spanning filaments, an unseen web that threads through the void, shaping the very architecture of the universe. And here's what's wild, we don't know how they got there. Picture this, a galaxy forms, its stars igniting, its spiral arms swirling, but all the while, it's swimming through an ocean of magnetism we can barely detect. These fields are faint, 1,000,000 times weaker than Earth's, yet their reach is staggering. Some stretch between galaxy clusters, linking cosmic structures like invisible highways. Others coil around entire superclusters, as if the universe itself is sketching blueprints in magnetic ink. The most surprising part, these fields aren't random. They're organized, coherent, as if woven by some grand design. So where did they come from? One theory points to the universe's infancy. In the first seconds after the Big Bang, quantum fluctuations might have imprinted tiny magnetic seeds into the fabric of space. As the cosmos expanded, these seeds stretched and amplified, growing into the colossal fields we see today. It's like stretching a rubber band. A faint pattern becomes a visible strand. But there's a problem. The math doesn't quite add up. These primordial fields should have faded long before reaching their current scale. That's where dark matter enters the story. Some researchers speculate that exotic particles, actions, or sterile neutrinos could interact in ways that generate or sustain these fields. Imagine dark matter as a cosmic loom, its invisible threads spinning magnetism into existence. Others propose even wilder ideas, that the fields are remnants of cosmic strings, hypothetical defects in space-time left over from the universe's birth, vibrating like guitar strings and humming with magnetic energy. But the real mystery isn't just their origin, it's their power. These fields influence how galaxies form, how gas flows between them, even how cosmic rays race across the void. They're not passive bystanders, they're active players in the universe's evolution. Take the famous Whirlpool Galaxy. Observations reveal its magnetic field isn't just draped over it like a blanket, it's twisted, following the spiral arms, as if the galaxy and its field are dancing together. Could this be evidence of a deeper connection? Some scientists wonder if magnetism is more than a force. It might be a kind of cosmic language, a way for the universe to transmit information across vast distances. After all, life on Earth depends on magnetic fields. Migratory birds navigate by them, and even our cells respond to their subtle pull. If fields this vast exist, could they be part of a larger, living network? The hunt for answers is heating up. New telescopes like the Square Kilometre Array will map these fields with unprecedented precision, tracing their threads back to the dawn of time. What they find could rewrite our understanding of cosmic evolution, not just how galaxies grow, but how the universe itself communicates, remembers, and perhaps even lives. Because if magnetism is the universe's invisible web, we're only just beginning to feel its vibrations. Rising from the heart of our galaxy like twin titans, the Fermi Bubbles stretch 50,000 light-years into space, one above the Milky Way's disk, one below. These colossal structures glow with gamma rays, the universe's highest energy light, a silent scream from some long-forgotten cataclysm. Discovered just over a decade ago, they're not just remnants of a cosmic event, they're a forensic snapshot of violence on a scale we can barely fathom. The mystery isn't just their size, it's what could possibly have unleashed enough energy to punch 2 holes through the fabric of our galaxy, the leading suspect. Our supermassive black hole, Sagittarius A, currently dormant but clearly capable of ancient fury. Picture a sleeping dragon that once belched fire across the cosmos. Astronomers calculate that the bubbles required an explosion 1,000,000 times stronger than a supernova, a blast so intense it would have lit up the night sky for civilizations across the local universe. Yet here's the puzzle: no known black hole activity matches the timing. The bubble's edges suggest they formed millions of years ago, but our galaxy's core shows no signs of such recent trauma. It's like finding a crater with no record of the impact. Then there's the odd shape. These aren't messy splatters of energy, they're eerily symmetrical, as if sculpted by some unseen force. Some researchers propose that magnetic fields funneled the eruption, shaping it into smooth lobes. Others wonder if dark matter played a role. If certain particles collided near the galactic center, they could have annihilated in a chain reaction, unleashing the gamma-ray tsunami we see today. But the most radical theory, the bubbles might be signatures of a long-extinct civilization, not aliens, but a natural intelligence. Some models suggest advanced life could harness black hole energy, leaving behind megastructures we're only now learning to detect. What's certain is this: the Fermi Bubbles are relics of a time when our quiet galactic neighborhood was anything but peaceful. They remind us that even familiar skies hold secrets of unimaginable power, and that the universe's past might be far more explosive than we ever dreamed. On a quiet August night in 1977, a radio telescope in Ohio picked up something extraordinary, a signal so powerful, so unusual, that the astronomer who discovered it scrawled, "Wow," in red ink across the printout. For 72 seconds, this burst of radio waves blazed from the constellation Sagittarius, dwarfing all background noise. Then, just as suddenly as it appeared, it vanished. Decades later, the WOW signal remains one of the most tantalizing cosmic mysteries, a flare of energy that defies every natural explanation we've thrown at it. Here's what makes it so baffling. The signal hit precisely 1420 MHz, a frequency known as the hydrogen line. Hydrogen is the most abundant element in the universe, and this specific frequency is where it naturally emits energy. It's also considered a prime channel for interstellar communication, since any technologically advanced civilization might recognize its significance. The signal was narrowband, meaning it occupied an extremely tight range of frequencies, unlike the messy, broadband emissions of stars or quasars. It was as if someone tuned a cosmic radio to the universe's most obvious station and broadcast a perfect, fleeting note. Scientists have ruled out nearly every conventional source. It wasn't a passing satellite or aircraft; those leave distinct Doppler shifts, and the WOW signal showed none. It wasn't a planet or comet. Jupiter and known comets were nowhere near that patch of sky. Even exotic astrophysical phenomena like pulsars or gamma-ray bursts don't match its profile. The signal came from a region with no notable stars or galaxies, a seemingly empty stretch of space. And here's the kicker: despite 40 years of relentless searching, it's never been detected again. Theories range from the plausible to the extraordinary. Some suggest it was an amplified burst from a rogue natural source, maybe a previously unknown type of cosmic maser, where interstellar gas clouds act like celestial amplifiers. Others propose it was a reflection of earthly radio waves off space debris, though the odds of such a perfect, one-time echo are astronomically low. Then there's the electrifying possibility: what if it was artificial? Not necessarily a message, but perhaps a leakage from some distant technology, an alien radar, a power beam, or even the wake of a starship's engine. But the real enigma isn't just the signal itself, it's the silence that followed. If it was a deliberate broadcast, why no repetition? If accidental, why haven't we caught similar blips? The WOW signal hangs in scientific limbo, a riddle that refuses to be solved. It's a reminder that the universe might be shouting at us in a language we don't yet understand, or worse, that we're listening for the wrong things entirely. Perhaps the most haunting thought is this: in a cosmos teeming with unexplained phenomena, the wow signal stands out precisely because it's so clean, so engineered. Like finding a single, polished gear in the middle of a wilderness, it begs the question, are we alone in the universe, or was that 72 seconds our first brush with something or someone else? Until we hear it again, we're left with nothing but a red-inked exclamation on a faded printout, and the growing suspicion that the universe is far stranger and far noisier than we ever imagined. At the heart of every black hole lies a riddle so profound, it threatens to unravel our understanding of reality itself, the information paradox. Picture throwing a book into a fire. The pages burn, the ink fades, but in theory, every word could be reconstructed from the smoke and ash. Now imagine that fire is a black hole. According to Einstein's relativity, everything that crosses its event horizon, books, stars, even light, is crushed into a singularity, erased from the universe forever. But quantum mechanics insists that information can never truly be destroyed. So where does it go? This isn't just academic quibbling. The answer could reveal whether the universe forgets or remembers. For decades, physicists assumed the information was simply lost until Stephen Hawking flipped the script. His calculations showed black holes slowly evaporate, emitting radiation that carries no trace of what fell in. It was as if the universe had a cosmic shredder, obliterating the past. The scientific community recoiled. If Hawking was right, reality would be fundamentally unpredictable, a nightmare for physics. Then came the holographic principle, a radical idea suggesting black holes don't destroy information but encode it on their surfaces, like a celestial DVD. Every particle swallowed might leave a fingerprint on the event horizon, a pixel in a cosmic hologram preserving the universe's memory. Recent breakthroughs add fuel to the fire. Simulations of quantum hair propose that black holes leave faint imprints in their gravitational fields, subtle wrinkles that record what fell in. It's as if space-time itself has a filing system, etching data into the fabric of reality. Even stranger, some models suggest black holes might not have singularities at all. Instead, they could harbor fuzzballs, tangled knots of strings vibrating with the preserved data of everything they've consumed. Imagine a black hole not as a cosmic trash compactor, but as a library, its walls lined with the stories of swallowed stars, but the wildest implication. If black holes preserve information, the universe might be self-updating, a vast learning system where every event leaves a trace. Think of it like a cosmic immune system. Black holes could be processing experiences, distilling the laws of physics from accumulated data. Some theorists even speculate that this feedback loop might explain why constants like gravity's strength seem so finely tuned for life, because the universe, in some sense, is tuning itself. The paradox isn't just about black holes, it's a litmus test for reality's deepest nature. Are we living in a universe that forgets, where the past vanishes without a trace? Or one that remembers, where every moment is etched into the cosmos, shaping what comes next? The answer might not just rewrite textbooks, it could redefine what it means to exist. Stretching over 1 billion light-years across the constellation, Eridana lies one of the universe's most puzzling empty spaces, a cosmic desert so vast, it defies explanation. Known as the Eridana Supervoid, this colossal region isn't just a random gap in the galactic web. It's a staggering absence, a bubble of near-nothingness where galaxies should be crowding the darkness, but instead, the void yawns wide. What's truly unsettling isn't just the emptiness, it's how this void bends the very fabric of reality around it. Light passing through the supervoid behaves oddly, as if space itself has a cold spot. When astronomers mapped the cosmic microwave background, the afterglow of the Big Bang, they found a chilling anomaly, a patch of cooler radiation aligning perfectly with the void's location. It's as if the light, stretched thin by the void's lack of gravitational pull, lost energy on its journey, leaving behind a shadow. But here's the problem: according to our models, voids this large shouldn't exist. The universe's structure should resemble a sponge with evenly distributed holes. The Eridana Supervoid is more like a canyon, a cosmic oversight that shouldn't be possible under standard cosmology. So what carved out this emptiness? One theory suggests it's the imprint of an ancient collision with another universe. Imagine two soap bubbles floating in a multiverse foam where they briefly touched. Matter might have been repelled, leaving behind a scar of negative pressure. Others propose the void is a rare statistical fluke, a cosmic lottery where matter just happened to clump elsewhere. But the most radical idea, the supervoid might be evidence of modified gravity, a sign that Einstein's equations break down at scales this vast. If gravity weakens more than predicted over enormous distances, it could explain why the void's edges aren't pulling galaxies inward as they should. Then there's the eerie silence. Galaxies at the supervoid's fringes seem to orbit its emptiness as if held back by some invisible barrier, like water circling a drain. Could dark energy be at work here, pushing matter away from the void's center? Or is the void itself somehow feeding on space-time, growing larger as the universe expands? The questions pile up faster than answers. What's clear is this: the Eridana Supervoid isn't just a blank spot on the map. It's a challenge to everything we thought we knew about how the universe structures itself. If voids like this are more than cosmic accidents, they could rewrite the rules of gravity, reshape our understanding of dark energy, or even open a window to realities beyond our own. Until then, the void remains a silent, sprawling question mark in the cosmos. When NASA Pioneer 10 and 11 spacecraft ventured beyond the solar system, they carried humanity's hopes and a mystery no one anticipated. These robotic explorers, launched in the early 1970s, should have coasted smoothly into interstellar space, their trajectories predictable down to the millimeter. But something bizarre happened. Both probes began slowing down ever so slightly, as if an invisible hand was gently tugging them backward toward the sun. Scientists called it the Pioneer Anomaly, and for decades it defied every conventional explanation. Even after accounting for heat radiation and fuel leaks, a tiny but persistent deceleration remained, a ghostly force acting on the probes with the precision of a cosmic metronome. At first, researchers suspected mundane causes, perhaps a fuel line leak or thermal radiation from the spacecraft's plutonium power sources, nudging them off course. But the math refused to cooperate. The deceleration was too consistent, too uniform across both probes, separated by billions of miles. It was as if the universe itself had added an unspoken rule to the laws of physics, one that only revealed itself at the fringes of our solar system. The anomaly was small, roughly 10 billion times weaker than Earth's gravity, but in the pristine silence of deep space, even the faintest whisper can echo loudly. Then came the tantalizing theories. Could dark matter, the elusive substance making up most of the universe's mass, be clustering near our solar system, its gravitational pull subtly breaking the pioneers? Or was something even stranger at work? Some physicists proposed modifications to Einstein's general relativity, suggesting gravity might behave differently over vast distances. Others dared to speculate about extra dimensions, unseen realms where forces could leak into our universe, tugging on the probes from directions we can't perceive. Imagine a fish in a pond, unaware of the hand stirring the water from above. Could the pioneers have brushed against the edges of a hidden dimension? The plot thickened when New Horizons' NASA Pluto probe failed to exhibit the same anomaly. Was the effect unique to the Pioneer's design, or had something fundamentally changed in the decades between their launches? The discrepancy only deepened the enigma. Then, in 2012, a team of researchers announced a breakthrough. After painstakingly reconstructing the probe's heat emissions, they concluded that thermal radiation radiating unevenly from the spacecraft's bodies could account for most of the anomaly. Case closed, not quite. Even their meticulous model left a residual discrepancy, a tiny but stubborn fraction of the slowdown unaccounted for. That lingering uncertainty is what keeps scientists awake at night. Because if even a sliver of the anomaly remains unexplained, it opens a door, a crack in our understanding of reality. Perhaps the pioneers encountered a previously unknown quantum effect, a subtle interaction between matter and the fabric of space-time itself. Or maybe the anomaly is a fingerprint of something grander, a flaw in our cosmic maps, hinting that gravity, dark matter, or even the structure of the void beyond our solar system isn't quite what we've assumed. The Pioneer's silent journey continues, their faint signals long faded but their mystery still pulsing through the scientific imagination. They remind us that even in the emptiness of space, the universe loves to hide its secrets, not in grand explosions or flashing lights, but in the quiet, persistent drift of a spacecraft obeying laws we have yet to name. Beyond the orbit of Neptune, where sunlight fades to a dim twilight, the solar system doesn't taper off gently, it slams into a wall. Astronomers call it the Kuiper Cliff, and it's one of the most baffling boundaries in our cosmic neighborhood. Picture a highway that suddenly drops into nothingness. That's what happens to the Kuiper belt, the ring of icy debris circling our solar system. For billions of miles, objects like Pluto and its kin drift in predictable orbits. Then, at around 50 astronomical units, 50 times Earth's distance from the Sun, the belt's population plummets. It's as if someone drew a line in the cosmic sand and declared, "No further." This isn't just a gradual thinning. The drop-off is shockingly abrupt, like flipping a switch. One moment, space is dotted with frozen worlds. The next, it's nearly empty. Standard models predict the Kuiper belt should extend hundreds of astronomical units deeper, with icy bodies peppering the void all the way to the Oort cloud. Yet the data doesn't lie. Something has swept this region clean, leaving behind a frontier that feels almost engineered. So what's carving this edge? The leading theory points to Planet 9, a hypothetical giant lurking in the darkness. If it exists, this unseen world, perhaps 10 times Earth's mass, could be herding Kuiper belt objects like a gravitational sheepdog, kicking some inward while ejecting others into interstellar space. Simulations show how such a planet could sculpt the cliff's sharp edge over billions of years, leaving behind the eerie emptiness we observe today, but not everyone's convinced. Some researchers argue the gap might be a relic of the solar system's violent youth, a fossilized imprint from the Sun's long-lost sibling star. Early in its life, our Sun likely formed in a dense cluster with thousands of others. A close pass from one of these stellar siblings could have stripped the outer Kuiper belt in a single gravitational tug, like a thief swiping coins from a table. Others propose even wilder ideas, that the cliff marks the edge of the Sun's magnetic influence, a zone where interstellar space begins to dominate, or even the shadow of a primordial black hole, its gravity quietly hoarding icy debris. The most unsettling possibility, the Kuiper Cliff might not be unique. Around other stars, astronomers have spotted similar gaps in debris disks, regions where planetary building blocks just stop. If these boundaries are common, they could hint at unseen forces shaping solar systems galaxy-wide, a hidden rulebook for how planetary families assemble. For now, the cliff remains a silent sentinel, guarding the frontier between the known and the unknown. Every icy body we discover near this edge, like the bizarrely tilted Sedna or the far-flung Goblin, offers fresh clues. Some may even be lured into strange orbits by Planet Nine's pull, acting as breadcrumbs leading to the solar system's last great undiscovered world. So while the Kuiper Cliff feels like an ending, it might really be a doorway, one that opens onto a realm of giants, lost stars, or physics we've yet to imagine. And as our probes push deeper into the darkness, they're not just exploring space, they're stepping up to the edge of a cosmic stage, waiting for the curtain to rise. Buried in the motions of millions of stars, astronomers have uncovered a hidden chapter of our galaxy's past, a violent collision frozen in time. Meet the Gaia Sausage, a strange cluster of stars hurtling through the Milky Way on elongated, sausage-shaped orbits. These aren't just random wanderers, they're the shattered remains of a dwarf galaxy that smashed into our own billions of years ago, an event so cataclysmic it permanently warped the Milky Way's structure. The discovery came from the European Space Agency's Gaia mission, which mapped the positions and velocities of over 1 billion stars with unprecedented precision. When researchers analyzed the data, they spotted something extraordinary. Thousands of stars moving in radical, plunging trajectories, cutting perpendicularly through the galactic disk like knives. Unlike the orderly, circular orbits of most Milky Way stars, these outliers loop wildly, their paths stretched into eccentric ovals resembling, yes, a cosmic sausage. This isn't just a quirky pattern, it's a smoking gun. Simulations reveal these stars bear all the hallmarks of an ancient galactic merger. Around 8 to 10 billion years ago, a dwarf galaxy roughly 1/10 the Milky Way's mass came screaming into our neighborhood. The collision wasn't a gentle merging of clouds, it was a demolition derby. The smaller galaxy was torn apart by tidal forces, its stars scattered into chaotic orbits that still bear the scars of that violent encounter today. But the real surprise, this event didn't just add stars to our galaxy, it reshaped it. The impact likely thickened the Milky Way's disk, puffing it up into the structure we see now. Some scientists even speculate the collision triggered a burst of star formation, seeding new stellar generations with the debris of the wreck. It's as if the universe left us a forensic trail. The Gaia Sausage stars are the blood spatter, and their orbits are the bullet trajectories pointing back to the crime scene. Here's where it gets even wilder. The sausage stars aren't just relics, they're active participants in our galaxy's evolution. Their gravitational pull still influences the Milky Way's rotation, like a spoon stirring a cup of coffee long after it's been dipped in. Some researchers believe similar mergers could explain other galactic mysteries, like the strange, thick disk of stars surrounding our galaxy's core. The implications stretch far beyond our cosmic backyard. If the Milky Way grew by cannibalizing smaller galaxies, it suggests a universe where galaxies aren't born, they're built piece by violent piece. The Gaia Sausage might be just one of many such fossils lurking in the stellar record, each telling the story of a collision that shaped the cosmos. So the next time you gaze at the night sky, remember, those tranquil stars are hiding a turbulent past. The Milky Way wasn't always this serene spiral. It's a mosaic of cosmic wreckage, a living museum where every star has a story, and some of them trace back to a cataclysm so vast, its echoes still ripple through our galaxy today. In October 2017, astronomers spotted something streaking through our solar system that didn't belong, a strange, tumbling object moving too fast to be tied to the sun's gravity. Named Amuamua, Hawaiian for scout, it was the first confirmed visitor from interstellar space, and its behavior was anything but ordinary. At first glance, it resembled an asteroid or comet, but as scientists tracked its trajectory, they realized this cosmic interloper wasn't following the rules. Instead of coasting predictably, Amuamua accelerated as it raced away from the sun, as if propelled by an unseen force. Theories erupted. Some suggested it was a nitrogen iceberg, sublimating in sunlight like a dry ice cube on a hot sidewalk, the escaping gas giving it a gentle push. Others pointed to hydrogen outgassing, a process where molecular hydrogen, trapped in icy layers, vaporizes and provides thrust. But here's the catch: no visible coma or tail, the usual hallmarks of outgassing, was ever detected. It was as if Amuamua was venting invisible exhaust, leaving no trace of its propulsion. Then came the more provocative ideas. The object's shape elongated, possibly 10 times longer than it was wide, defied natural odds. Most space rocks are lumpy, not cigar-shaped. Its brightness also fluctuated wildly as it tumbled, suggesting a highly reflective metallic surface. Could it be debris from an alien civilization? A light sail fragment broken off some distant starship and sent adrift. The hypothesis, while fringe, wasn't entirely dismissed. After all, Amuamua's acceleration profile matched what we'd expect from a thin, sunlight-powered sail. But the real mystery lies in what we didn't see. When other interstellar objects like Borisov, a more conventional comet, passed through, they behaved predictably. Amuamua didn't. It left behind more questions than answers. Was it a statistical fluke, a rare type of cosmic debris we'd simply never encountered before? Or was it a glimpse of something far stranger? A class of objects that operate by rules we don't yet understand. The implications are staggering. If Amuamua was natural, it suggests entire populations of exotic interstellar objects lurk in the void, made of materials or shaped by processes unlike anything in our solar system. If it was artificial, or even just unusual, it raises the tantalizing possibility that the cosmos is littered with artifacts of other civilizations, drifting silently between the stars. One thing's certain: Amuamua was a wake-up call. The universe isn't just sending us comets and asteroids, it's sending enigmas. And with every strange visitor that slips through our cosmic neighborhood, we're reminded how much we still have to learn about what's out there. Tucked away in the cosmic microwave background, the faint glow left over from the Big Bang, there's a region so cold, it sends shivers down the spines of cosmologists. Known as the CMB Cold Spot, this eerie anomaly stretches over 1 billion light-years across, a blister of chill in an otherwise uniform sea of primordial radiation. At first glance, it might seem like a statistical fluke, a random dip in temperature, but the odds of such a pronounced cold spot forming naturally, less than 1 in 200. This isn't just a cosmic quirk, it's a screaming outlier, a fingerprint on the universe that shouldn't be there. So what could explain it? One of the most electrifying theories suggests this spot might be a bruise, a collision scar from a parallel universe bumping into ours in the distant past. Picture 2 soap bubbles floating in a froth of multiverses. Where they gently touch, their membranes might repel each other, leaving behind a subtle dimple in the fabric of space-time. In this scenario, the cold spot would be the aftermath of that encounter, a patch of space drained of energy by the brief, gravitational tug of war with another reality. It's a radical idea, but the math holds up. Such a collision could precisely account for the spot's size, shape, and temperature deficit. Of course, not everyone's convinced. Skeptics argue it could just be a vast supervoid, a region of space unusually empty of galaxies and matter, stretching the light passing through it and cooling the CMB. But here's the catch: surveys haven't found a void large or deep enough to explain the cold spot's intensity. The discrepancy is glaring, like trying to explain a crater with a pebble. Other theories propose exotic physics like a cosmic texture, a defect in space-time left over from the universe's birth, warping the background radiation like a wrinkle in a sheet. Yet the multiverse hypothesis lingers, tantalizingly hard to dismiss. If true, it would mean our universe isn't just one reality among many. It's part of an infinite foam of bubble universes, each with its own laws of physics, its own history, its own version of existence. The cold spot could be our first tangible evidence that such a reality exists, a crack in the door to the unimaginable. Think about the implications. If another universe brushed against ours, what else might be out there? Are there universes where gravity is stronger, where time runs backward, where the constants of nature are rearranged? The cold spot doesn't just challenge our understanding of cosmology, it rewrites the script of reality itself. And until we can peer deeper into its mystery, it remains one of the universe's most provocative whispers, a cold, silent question mark hanging in the cosmic dark. High above the galactic plane, floating in the constellation Monoceros, lies one of the most peculiar structures ever observed, the Red Rectangle Nebula. At first glance, it looks like a celestial jewel box, its crimson hues glowing against the blackness of space. But zoom in closer, and the real wonder reveals itself. A series of ladder-like rungs stretching across the nebula's core, perfectly symmetrical, as if sketched by some cosmic architect. These aren't random cosmic brushstrokes, they're eerily reminiscent of molecular bonds, the same patterns that form the backbone of DNA here on Earth. The resemblance is uncanny. The nebula's rungs mirror the double helix structure of organic molecules, the very building blocks of life. Coincidence? Maybe, but when astronomers analyzed the nebula's light signature, they found something even more startling. Complex organic compounds like anthracene and pyrene, molecules often linked to prebiotic chemistry. It's as if the universe isn't just hosting life, it's broadcasting the blueprint. This raises a profound question. Could the universe have a built-in bias toward complexity? The red rectangle's patterns aren't unique. Similar ladder-like structures have been spotted in other planetary nebulae, suggesting these formations might be cosmic constants rather than flukes. Some scientists speculate that the same physical processes shaping these nebula ladders could also govern how molecules assemble in interstellar space, nudging matter toward ever more intricate arrangements. Think of it like a cosmic assembly line, gravity, radiation, and magnetic fields working in concert to weave simple atoms into the precursors of life. Then there's the bigger picture. If organic molecules are forming so readily in environments like the red rectangle, it implies the raw ingredients for life might be scattered everywhere, waiting for the right conditions to ignite. The nebula's central star, a dying sun shedding its outer layers, is essentially a chemical factory, forging complex molecules in its turbulent winds. In a sense, stars like this could be the universe's way of sowing the seeds of life long before planets even form. But the most tantalizing idea isn't just about chemistry, it's about pattern. The red rectangle's symmetry hints at a deeper order, a kind of cosmic grammar where matter organizes itself into repeating, life-friendly structures. From the spirals of galaxies to the branching of neurons, nature seems obsessed with certain shapes. Could these patterns be more than aesthetic? Could they be evidence of universal rules that favor complexity, even intelligence? The red rectangle doesn't just glow, it whispers. Its rungs might be a clue that life isn't an accident but an inevitability, written into the fabric of space itself. And if that's true, then every star, every nebula, every drifting molecule could be part of a story far grander than we've dared to imagine. A story where the universe isn't just alive, but growing, learning, and perhaps even remembering. In the heart of the Large Magellanic Cloud, a satellite galaxy orbiting our Milky Way, the Tarantula Nebula erupts with a spectacle unlike anything else in the local universe, a tsunami of star birth so violent it reshapes the cosmos around it. This isn't just a cluster of young stars, it's a chain reaction, a celestial domino effect where each stellar ignition triggers the next in a runaway explosion of creation. Imagine tossing a pebble into a pond and watching the ripples grow into tidal waves. That's what's happening here, but on a scale where the pebbles are collapsing gas clouds and the waves are walls of radiation carving through space. At the nebula's core lies R136, a star cluster so dense with massive young suns, it outshines entire galaxies. The radiation from these stellar titans blows bubbles in the surrounding gas, compressing it into dense shells where new stars ignite like firecrackers along a fuse. But here's the mystery: the pattern isn't random. Star formation ripples outward in coordinated waves, as if the nebula itself is conducting an orchestra of creation. Some astronomers compare it to a wildfire where each new star's birth provides the spark for the next, except in this case, the flames are the blue-white blaze of nuclear fusion, and the fuel is an interstellar gas laced with cosmic dust. What's truly staggering is the speed. In most nebulae, star formation is a slow, meandering process, taking millions of years to coax a single sun from the void. But in the Tarantula, stars burst to life in rapid-fire succession, their birth separated by mere thousands of years, a blink in cosmic terms. It's as if the nebula has tapped into some hidden reservoir of urgency, a celestial fast-forward button pressed by forces we don't yet understand. Could magnetic fields be channeling the chaos? Or is dark matter somehow funneling energy into this region, turning it into a stellar assembly line? Then there's the bigger question: is this how star formation always works, just on a grander scale? The Tarantula might be a scaled-down version of the processes that birthed the universe's first galaxies, where star tsunamis roared through pristine gas clouds, lighting up the cosmic dark ages. If true, it suggests a universe where creation isn't just a passive drift toward equilibrium, but an active, almost viral phenomenon, where stars beget more stars in cascades of light and energy. But the most haunting clue lies in the nebula's chemistry. The Tarantula's gas is rich with heavy elements forged in supernova, the remains of previous generations of stars. It's a cosmic recycling plant where death fuels new life in an endless loop. This isn't just a nebula, it's an ecosystem, a living network where matter and energy flow in cycles as intricate as any food web on Earth. So when we gaze at the Tarantula, we're not just seeing a stellar nursery. We're witnessing a universe that knows how to propagate itself, where the seeds of one generation sow the next in an unbroken chain stretching back to the Big Bang. And if stars can birth stars in these self-sustaining waves, what other cosmic rhythms might be pulsing through the dark, waiting to be discovered? At the heart of our galaxy, a cosmic detective story unfolds, one where the suspects have vanished without a trace. Astronomers call them intermediate mass black holes, the missing link between stellar black holes and supermassive giants like Sagittarius A. Theory says they should be everywhere, the stepping stones in black hole evolution, yet the Milky Way appears to have lost them. It's as if someone erased an entire chapter from our galactic history, leaving behind only whispers and unanswered questions. The puzzle begins with scale. Stellar black holes form when massive stars collapse, typically weighing between 5 and 50 solar masses. Supermassive black holes, like the 4 million solar mass beast at our galaxy's center, loom large in most big galaxies. But the middle ground, black holes ranging from hundreds to hundreds of thousands of solar masses, remains eerily empty. These intermediate mass black holes should be the glue connecting the two extremes, the cosmic bridges showing how small black holes merge and grow over time. Yet despite decades of searching, only a handful of candidates have surfaced in our galaxy, and even those remain hotly debated. Where could they be hiding? One possibility is camouflage. Intermediate black holes might lurk in dense globular clusters, their gravitational signatures drowned out by swarms of surrounding stars. Take the candidate in Omega Centauri, a globular cluster where stars orbit an invisible mass equivalent to 40,000 suns. But even there, the evidence is circumstantial, a collective dance of stars hinting at an unseen partner, not the smoking gun of X-ray emissions or accretion disks we'd expect. Then there's the demolition theory. Perhaps these black holes didn't vanish, they were destroyed. When galaxies merge, their central black holes spiral inward and collide, often getting kicked out by gravitational waves in the process. Intermediate black holes might be the cosmic roadkill of these violent encounters, ejected into intergalactic space like billiard balls struck too hard. Simulations show this could explain their scarcity, but it raises another question. If they were thrown out, where are the rogue black holes drifting between galaxies? Our survey should have spotted them by now. The most unsettling explanation, maybe they never existed at all. Some models suggest supermassive black holes didn't grow gradually, but formed directly from collapsing gas clouds in the early universe, skipping the intermediate stage entirely. If true, it would rewrite galactic evolution, implying a universe where black holes are born either small or enormous, with nothing in between. Yet the hunt continues. New telescopes like LISA, designed to detect gravitational waves from merging black holes, could finally settle the debate. If intermediate mass black holes are out there, their collisions should send ripples through space-time loud enough for us to hear. Until then, their absence remains one of the Milky Way's most stubborn mysteries, a reminder that even in our own cosmic backyard, the universe still keeps its deepest secrets close. Deep in the constellation Serpens, a star's corpse spins at dizzying speeds, its beam of radiation slicing through the cosmos like a lighthouse in the dark. But the real marvel isn't the pulsar, it's what orbits it. Meet Pulsar J1719-1438b, a planet so dense, so bizarre, that scientists believe it's made almost entirely of crystallized carbon, a diamond the size of a world. This isn't science fiction. It's a cosmic reality that defies everything we thought we knew about how planets form. Imagine a star once larger than our Sun, its core rich with carbon, collapsing in a supernova so violent it left behind a neutron star no bigger than a city. The explosion's shockwave compressed the star's leftover material into a planet-sized crystal, a diamond forged in the heart of stellar catastrophe. The numbers are staggering. This world's density suggests its carbon has been crushed into diamond structure, with a surface harder than any gem on Earth. If you could stand on it, which you couldn't, given the crushing gravity and lethal radiation, you'd be walking on a landscape of pure gemstone, glittering under the glare of its undead sun. But here's what really twists the knife for planetary scientists. This world shouldn't exist. Traditional models say planets form from the gentle clumping of dust in protoplanetary disks, not the apocalyptic wreckage of a supernova. The diamond planet is a cosmic Hail Mary, a reminder that the universe doesn't just follow the rules, it rewrites them. And if this freak of nature exists, what else is out there? Planets of solid gold, worlds made of sapphire, the possibilities stretch the imagination. The pulsar's relentless radiation bathes the diamond world in an unending storm of high-energy particles, stripping away any atmosphere it might have once had and leaving behind a bare, glittering core. It's a hellish environment, yet somehow this planet endures, a testament to the universe's capacity for crafting wonders in the most hostile corners of space. And the implications go beyond mere spectacle. The Diamond Planet challenges our understanding of cosmic recycling. If supernova can forge planets from stellar ash, then the building blocks of worlds might be far more diverse than we ever dreamed. Carbon-rich systems could be factories for exotic worlds, their chemistry skewed toward the extraordinary. So while we marvel at this distant gem, remember, it's not just a curiosity. It's a beacon illuminating the untapped potential of the cosmos. Every time we assume we've seen it all, the universe responds by revealing something stranger, something more dazzling, proof that even in the cold void of space, there's no limit to its creativity. At the farthest edges of quantum physics, where the familiar rules of matter break down, scientists are chasing shadows particles that refuse to behave like particles at all. They've dubbed them unparticles, a term that sounds like something from a sci-fi novel, but represents one of the most perplexing mysteries in modern physics. Unlike protons, electrons, or even the elusive neutrinos, unparticles don't fit neatly into the standard models categories. They don't have a definite mass or obey the usual energy scales. Instead, they exist in a quantum limbo, blurring the line between particle and wave in ways that defy conventional understanding. The concept emerged from a radical idea. What if there's an entire sector of reality governed by forces and particles we've never detected? Just as dark matter silently shapes galaxies without interacting with light, unparticles could be weaving through the cosmos, invisible to our instruments yet subtly influencing the fabric of reality. The telltale clues come from high-energy particle collisions, where certain reactions leave behind energy patterns that don't match any known particle behavior. It's like finding footprints in the snow that don't belong to any animal you've ever seen. Their shape hints at something entirely new. Here's where it gets even stranger. Unparticles don't just challenge our taxonomy of matter, they upend our understanding of dimensionality itself. In traditional physics, particles exist in 3 dimensions of space and 1 of time. But unparticles might operate in fractional dimensions, their properties scaling in ways that make them seem neither fully here nor there. Imagine a shadow that doesn't darken smoothly but flickers in and out of existence, its intensity changing unpredictably. That's the eerie behavior. Unparticles might exhibit a kind of quantum half-life that doesn't play by the rules. The implications ripple far beyond theory. If unparticles exist, they could be the missing link to dark matter, the invisible glue holding galaxies together. Some models suggest these enigmatic entities might interact with ordinary matter only through gravity, making them nearly impossible to detect directly. Yet their presence could explain anomalies in neutron star behavior, cosmic ray distributions, even the way certain atomic nuclei absorb energy. It's as if the universe has been leaving breadcrumbs all along, pointing to a hidden layer of reality just beyond our grasp. Critics argue that unparticle physics is speculative, a mathematical curiosity without experimental proof. But history has shown that the most revolutionary ideas often start as whispers in the data. The neutrino was once a hypothetical particle, invented to balance the equations of radioactive decay until it was discovered decades later. Could unparticles follow the same path? New experiments at facilities like the Large Hadron Collider are searching for their fingerprints, hunting for energy imbalances or unusual decay patterns that might betray their presence. What's at stake isn't just another entry in the particle zoo. Unparticles represent a paradigm shift, a hint that the universe's building blocks might be far weirder, far more fluid than we ever imagined. They suggest a cosmos where matter isn't just solid or liquid, wave or particle, but something in between, a spectrum of existence we're only beginning to explore. And if we can prove they're real, it won't just expand the frontier of physics. It'll tear down the fence entirely, revealing a wilder, more mysterious universe than we ever thought possible. Imagine a cosmic ledger where every element has its place, a balance sheet written in the aftermath of the Big Bang. According to the math, the universe should contain a precise amount of lithium, the third lightest element, forged in those first fiery minutes of creation. But when astronomers tally up the lithium in ancient stars and interstellar gas, the numbers don't add up. Roughly 3 times as much lithium should exist as we've found. It's as if the universe misplaced an entire atomic fortune, and the mystery only deepens when you realize this isn't just a rounding error, it's a glaring gap in our cosmic accounting. Where did the lithium go? One possibility is destruction. Early stars, hotter and more turbulent than their modern counterparts, might have burned through their lithium like kindling, fusing it into heavier elements in their cores. Picture a blacksmith's furnace where raw ore is hammered into tools, except here, the furnace is a star and the tools are atoms of helium or beryllium. But simulations show this alone can't explain the deficit. There's simply too much missing lithium for stellar processes to account for it all. Then there's the recycling theory. Some physicists propose that lithium gets trapped in cosmic dust grains or locked away in the atmospheres of brown dwarfs, those failed stars too cool to ignite hydrogen fusion. It's like misplacing your keys in the couch cushions. The lithium isn't gone, just hiding in plain sight. Yet even these hiding spots fall short of balancing the books. The most tantalizing explanation: we might be missing a fundamental piece of nuclear physics. The Big Bang nucleosynthesis models, our gold standard for how light elements formed, could have a blind spot, an overlooked reaction pathway that either destroyed lithium faster than predicted or prevented its formation in the first place. Here's where it gets radical. Lithium's absence might not be a flaw but a clue, a fingerprint of exotic physics at work in the early universe. Some theories suggest dark matter particles could have interacted with lithium nuclei, breaking them apart or altering their abundance. Others speculate that the universe underwent a phase transition shortly after the Big Bang, a sudden shift in the laws of physics that scrubbed lithium from the cosmic record. It's like finding a page torn from a history book, its absence hinting at a chapter we never knew existed. The stakes are higher than they seem. If standard cosmology can't account for lithium, what else might it have wrong? The element's scarcity challenges our narrative of how the universe evolved, suggesting gaps in our understanding of everything from stellar chemistry to the nature of dark matter. But it also offers a rare opportunity. Lithium isn't just missing, it's a messenger, a relic from the universe's first moments that might hold the key to truths we've yet to uncover. So while the missing lithium problem might sound like a niche puzzle, it's really a cosmic detective story. Every ancient star we study, every galaxy we map, adds another piece to the mystery. And if we can solve it, we won't just find a few lost atoms, we might rewrite the story of creation itself. What if reality isn't what it seems, not just in the philosophical sense, but in the most literal way possible? What if the universe, with all its galaxies, stars, and conscious beings, is nothing more than an elaborate simulation? The idea might sound like sci-fi, but some of the brightest minds in physics and philosophy take it seriously. The simulation hypothesis suggests that our entire existence could be a programmed construct, a digital universe running on some unfathomable cosmic computer. And the eerie part, the deeper we probe the fabric of reality, the more it seems to behave like lines of code. Take quantum mechanics, for instance. At the subatomic level, particles don't follow the predictable rules of classical physics. Instead, they exist in fuzzy superpositions, multiple states at once until observed, at which point they choose a definite position. This wave function collapse feels less like a law of nature and more like a rendering trick, a way to save processing power by only calculating the details when someone's looking. It's as if the universe has a built-in optimization algorithm, simplifying computations until an observer forces it to render the full picture. Even Albert Einstein found this behavior so unsettling, he famously quipped that God does not play dice with the universe. But what if the dice rolls aren't random, just procedurally generated? Then there's the universe's pixelation. Just as a digital image breaks down into discrete pixels when zoomed in too far, space-time itself appears to have a fundamental limit to its divisibility, the Planck length. Below this scale, the concepts of space and time lose meaning, much like how a single pixel can't display half a color. Even energy comes in discrete packets or quanta, rather than a continuous flow. These aren't just quirks, they're exactly what you'd expect if reality were running on a finite, digital substrate. But the most provocative evidence might be the glitches. Every complex system has bugs, and if the universe is a simulation, its imperfections could be hiding in plain sight. Consider the Mandela effect, where large groups of people remember historical events differently, like the Berenstain Bears being spelled Berenstein. Could these collective false memories be artifacts of a universe that's been updated or edited? Or think about déjà vu, that uncanny feeling of reliving a moment. In a simulation, it might be as simple as a buffer error, a fleeting hiccup in the rendering process. Of course, skeptics push back. They argue that these phenomena have conventional explanations. Quantum mechanics is just weird. The Planck scale is a mathematical boundary, and memory is fallible. But here's where the simulation hypothesis gets even stranger. If we're living in a programmed reality, the creators might have left intentional signatures, Easter eggs hidden in the fabric of physics. Some theorists suggest searching for unnatural constraints in cosmic ray energies or mathematical patterns in the constants of nature, like the fine structure constant. A simulated universe might have hard-coded limits or repeating sequences, like a video game's procedural generation revealing its underlying algorithms. The implications are dizzying. If we're simulations, does free will exist, or are our choices predetermined by the simulation's code? Are the creators themselves simulations in a higher-level reality, nesting dolls of existence stretching infinitely upward? And if we someday create conscious simulations of our own, does that make it more or less likely that we're already in one? The hypothesis doesn't just challenge our place in the cosmos, it redefines what real even means. Perhaps the most unsettling question isn't whether we're in a simulation, but why we're in one. Are we someone's science experiment, a historical reenactment, or just entertainment for an advanced civilization? Or worse, what if we're abandoned code, a forgotten simulation running in the background of some unimaginable machine? The simulation hypothesis forces us to confront the possibility that all of human history, every triumph and tragedy, might be nothing more than a subroutine in a cosmic processor. Yet for all its existential weight, the idea isn't entirely bleak. If the universe is a simulation, it's one of staggering complexity and beauty, capable of generating black holes, supernova, and conscious minds that can question their own existence. That in itself is a kind of miracle, coded or not. And if we ever prove we're living in a simulation, it wouldn't diminish reality. It would expand it, revealing layers of possibility we've only begun to dream of. After all, even if we're made of bits and bytes, the wonder we feel when we gaze at the stars is undeniably real. From galactic heartbeats to cosmic voids whispering secrets from beyond, these 25 observations shatter the illusion of a static, lifeless universe. What emerges instead is a breathtaking portrait of reality as something far stranger, a vast, interconnected network pulsing with rhythms we're only beginning to decipher. Think of each discovery as a ripple in a pond we've just noticed, hinting at depths below the surface we never imagined. The galaxies breathing in star-forming cycles, the magnetic threads stitching space together, even the eerie synchronicity of fast radio bursts, they all point toward a cosmos that doesn't just exist but participates. This isn't poetic metaphor. The data itself suggests the universe operates with a coherence that borders on intention. Take dark flow dragging galaxies toward some unseen horizon, or the Great Attractor's invisible grip. These aren't random anomalies. They're evidence of a reality where gravity, energy, and even the vacuum of space itself act in concert, like instruments in an orchestra we've only just learned to hear. And then there's the quantum realm, where particles flicker in and out of existence, not as chaos, but as if following some deeper script. Even the missing lithium and the simulation hypothesis whisper the same tantalizing question. What if the universe isn't just a stage, but a story? So what does it mean for us? If the cosmos is this dynamic, this responsive, then humanity isn't just a bystander. We're embedded in the narrative. Our very act of observation changes quantum states. Our curiosity sends probes like the pioneers to test the boundaries of physics. Some theorists even suggest consciousness itself might play a role in shaping reality, that the universe evolves not just through blind chance, but through the attention of beings who can perceive it. It's a dizzying thought. We might not just live in this living universe, we might be how it knows itself. The implications stretch beyond science into philosophy, art, even spirituality. If the universe learns, remembers, and adapts, does that make it akin to a mind? Are black holes the universe's way of recycling information, or the cosmic microwave background its memory? And if we're part of this web, what responsibilities come with that connection? Every time we look up, we're not just studying the cosmos, we're conversing with it. This is where the journey truly begins. Each mystery solved unveils 10 more, and that's the thrill of exploration. Whether your team, multiverse, or suspect the Fermi Bubbles hide alien megastructures, one thing's certain. The old models of a cold, mechanical universe are crumbling. In their place rises a vision of reality so vibrant, so alive, it redefines what it means to be part of something greater. So keep questioning, keep wondering, and above all, keep listening. The cosmos has been speaking for 13.8 billion years, and if these observations tell us anything, it's that the most astonishing chapters are still being written. Now it's your turn. Which of these 25 observations reshaped your view of reality? Drop your thoughts below, and let's keep the conversation cosmic. And if you're hungry for more deep dives into the universe's grandest mysteries, hit subscribe. The next revelation is always just beyond the horizon.